Hey everyone, this is section 4.2. Let's just jump right into it. So where I want to start to kind of motivate this lesson is I want to start by graphing this equation right here. So I have a table. I want you to pause the video, go ahead and fill in the table in accordance with this function here, and then graph the points, hit play when you're ready to check your answers. Okay, so to begin, I'm going to plug in 3, and I'll do the work over here. So let's see, I've got 2 times 3 minus 3y equals 6. So let's see, this is 6 minus 3y equals 6. And so then I'll subtract off the 6's. I get negative 3y equals 0. Divide each side by negative 3. And I get y equals 0. So that would be the first point I'll fill in here. Now for the next one, I need to plug in x equals 0. So pause the video if you need this work. I'm going to just erase it. So now I'm going to plug in 0 for x. So this will be 2 times 0 minus 3y equals 6. So the 0 will just make everything fall out. So this becomes negative 3y equals 6. Divide each side by negative 3. I get y equals negative 2. So that's going to be the next thing that goes in my table. Okay, so now for the last one, now I'm going to do y equals negative 4. So once again, I'll just go ahead and just get rid of all this. And so now let's do 2x minus 3 times negative 4. That equals 6, not negative 6, my bad. Okay, so now I've got 2x plus 12 equals 6. Subtract off the 12. I get 2x equals negative 6. Divide each side by 2. And I get x equals negative 3, so I'll put that in here. Okay, so let's go ahead and plot these points. So I've got 1, 2, 3, 0. Then I've got 0, negative 2. And then I've got negative 1, 2, 3, and down 1, 2, 3, 4. Okay, so I've got these points, so they're going to make a line. Okay, so there we go. Okay, so that was the first part of this. So now what I want to do is I want to label these points as A, B, and C. So this is A, this is B, this is C. And now we want to understand the distances between each point. So starting with A to B, so I'll do it in this blue color. So here's A to B. Here's what I'm being asked to do. I want to determine the vertical distance versus the horizontal distance. So going from here to here, and then really from here to here. These are the two distances that I'm interested in. So this is the horizontal right here. So notice then, so if I start here A, I go 1, 2, 3 spots. So there's my horizontal distance. And then how far do I go up? So if I'm starting from here, I go up 1, 2. So there's my horizontal distance and my vertical distance. And now in this last column, what it's telling me to do is to just go ahead and note one over the other. Okay, so now I want you to do that for B to C. So go ahead and just count those out. Hit play when you're ready. So for B, so my horizontal distance, I've got 1, 2, 3, so same thing again. And then going up, this is 1, 2, so this is still 2, so this is the same ratio. And now finally, for this last one, I want to go from A to C. So I'm going all the way, so I'll have this little pink color here. So I'm going all this way. So now, if I go from here all the way over to C, this is 1, 2, 3, 4, 5, 6 points going this way. So there's my horizontal distance, and then going up, this is 1, 2, 3, 4. So there's my 4 points going up. So now if I just take a look at that ratio, this becomes 4 over 6, and what does that equal? That equals 2 over 3. So this question of, is the ratio between the vertical and horizontal distances consistent? So yes, it is. And this is actually what we're trying to talk about today. This ratio here, this is actually what's really contained in the idea of the slope, which a lot of people remember, but this is actually kind of what it's all about. Okay, so now let's talk about slope. So with lines, the ratio of the vertical to horizontal distance, this is always consistent. And it's one of the defining characteristics of a line, and we call this measure between the horizontal and vertical distance. This is our slope of the line. So there's a couple different ways that you can kind of calculate slope, and I want to just go through a few ground rules when we're working with this. So let's go ahead and start with this definition of a slope. So I've got this already written down for you. So slope, we usually use the letter M to indicate this, and it's this idea of rise over run or change in y over change of x. So a lot of people remember that, but there's a couple other things that they tend to forget. So moving down just a little bit, I have a few just things I want to remind you of with the slope. So in general, if you have 2 points and you're looking at them on a graph, so with slope, we kind of like to think of this like a book. So you always want to start with the leftmost point. Always read it like a book from left to right. Now, when the slope is negative, this means that you go down to get to the next point. And when the slope is positive, that means that you're going up to get to the next point. And so as far as like what direction we're going horizontally with slopes, we always think about negative is down, positive is up. And horizontally, so if we're starting from the left, we're always moving to the right horizontally. So this is just a good rule of thumb to have when you are investigating slopes. It's true that, I mean, you could count a slope going from right to left, but I find that very often people kind of get lost in some of the directions. So I like to just have like some basic ground rules that will always work versus kind of going into the weeds on, oh, well, you can start on the right if you do it like this, or you can start on the left if you do it like this. Let's just say that we're always just going to move from left to right. Okay, so what I want to do now is I want to just work on counting down a few slopes. So in this graph, so notice I have my point here. So I've got my point here, here, and here. So what we want to do is we just want to start from the left. So we will start at this point here. And now what I want to do is I really just want to start practicing counting out the slope. So just notice before you start how this graph works. So this is going up by ones. And so now I want to move, so it's rise over run. So I want to first look at my change in y. So I'll start here and I'm going to go up. So I'm going to go up this way. So this is for me to get to this point and then over this way. So this is what I really need to count out. So how far do I go up then? So it looks like I'm starting here and I go up 1, 2. So this is up 2. And then from this point, I go over 1, 2, 3. So I go up 2, and then I go right 3. Now I should be able to confirm that one more time going from here to here. So maybe I'll just do it just to make sure that I'm good. So I'll use a different color. So let's see, I'm going to go up this way, and then I'm going to go over this way. So if I just count this one more time, so let's see, I go up 1, 2, and then I go up right 1, 2, 3. So I definitely have the right slope. So you're going to use an M to indicate the slope, and then it's always this idea of your rise over your run. So up is positive, so this is up 2, so that's positive 2, and then you made a right turn to go 3, so it's 2 over 3. Okay, so let's do this again now with B. So starting with the leftmost point over here, why don't you go ahead and count out the slope just using what you know so far. Hit play when you're ready to check. Okay, so in this case now I'm going to go down this way and then over this way. So this is what I need to count out. So in this case I'm going down, let's see, 1, 1, 2. So I'm going down 2. And then I'm turning from here and I'm going over 1. So this is going to the right 1. So in this case then, my slope, I went down 2, so that's negative 2 over 1. And you always want to write your slope in the most simplified form, so this will just be m equals negative 2. Okay, so just a few more examples I want to look at here. So why don't we do this one? Same idea, why don't you pause the video, hit play when you're ready to check. Okay, so now I've got a point here and I've got a point here and I don't really see any other points in between. So I just want to kind of track what's going on from here to here. So I'm going to go from here and down. So here's kind of the path that I want to count out. So in this case, this is going up 1, 2. So this is up 2. And then from here, I'm going over 1, 2, 3, 4, 5, 6. So this is to the right 6. So now this is going to be 2 over 6, so ultimately my slope is 1/3. now moving on to this last one, so same idea. So moving from the left to the right, just count out the slope, hit play when you're ready. So here's my leftmost point. So I don't go up at all, but I do go over this way. So I still want to count this out in the same way. How far did I go up? I went up 0, right? And then I actually do go to the right. So in this case, I go to the right, let's see, 1, 2, 3. So this is right 3. So I'm still going to use the same slope calculation just to figure this out. So it was up 0 and then right 3. Well, what does that simplify to? That just simplifies to 0. And so this is what a 0 slope looks like. It's a horizontal line. And that's totally fine. Okay, so I think this is actually a good place to stop this video. So I'll pause here and I'll see you guys in the next